Welcome back. I'm going to go through the homework that I just returned to you at the beginning of the class. I asked Rafi, Olivia, and Daisy, would they rather to go through the homework when you receive the graded homework back, or when you receive the homework that you just handed in? All three of them voted to talk about the homework that they just submitted, instead of that I just graded. So because of that, we need to go through two sets of homework. The one that you just submitted, which I just did at the beginning of the class, but I'm now also going to go through the homework that you just got back at the beginning of the class. Okay? So this is the homework about graph theory. So I think most of you get most of the questions correct. The second one that is about what is called the wheel graph. I think someone kind of misunderstood or didn't draw the pictures, right? In particular, when you do a math problems, you need to read the problems, okay? Both on the first one, path graph, and the second one, wheel graph, it tells you vertices, the number of vertices starting at 2 or starting at 4. So I think some of you basically completely misread or ignore that part of the question. That's one. Someone also didn't read the question carefully. The question asks you to draw the graph, not just come up with the formula. Okay. However, the question that I'm going to go through is the one that everyone got it wrong, which I'm not too surprised because this is the class that we had before the winter break. So it has to do with isomorphism. Does anyone want to give a shot on what isomorphism is? What does it mean by graph G and H isomorphic to one another? Anyone? No. So isomorphic meaning two graphs are exactly the same. When you rearrange the label of the vertices, you will find that where there are edges on one graph, the same vertices on the other graph also have an edge. Like basically you make the label of the two graphs the same, meaning the name of the vertices on the two graphs the same. Then when there's an edge on the left hand side, then there will be an edge on the right hand side, etc. Now in general, a few of you try to basically say it has the same number of vertices, the same number of edges, or the degrees of the vertices are the same. Last class, when we talk about graph theory, I emphasized to everyone that is a method for you to prove that two graphs are not isomorphic. Okay? Meaning if two graphs have different number of vertices, have different number of edges, have different number of degrees in the vertices, then that means they are not isomorphic. However, to prove two things that are isomorphic is in general very difficult. Okay, is in general a lot more work. Same as kind of proving something lies versus proving someone never lies. Okay, so you just have to catch someone once that they lie, and then you can call them a liar. But then for you to prove yourself to be honest is pretty difficult. Okay, so I'm going to do it this time. So this is called a utility graph. You can kind of ignore the name, but for you to remember why this is called utility graph. 3 houses, 1, 2, 3. 3 utility companies, 1, 2, 3. And then this is a good city where every house is connected to every utility company. So using the notation that we have last time, so basically the vertex set is 1, 2, 3, 4, 5, 6. And then can someone help me what are the edge? The first one is 1, 4. What's the second one?
5.
1, 5. Third one? 1,
1, 6.
1, 6. And then let's look at the second house. What's the first edge for second house?
2,
2, 4. And then 2, 5. And then 2, 6. And then finally the third house, we have 3, 4. 3, 5. Sorry, 3, 5. And then 3, 6. Okay. So I'm not going to go through all of them, but I'm going to take one of them, one of the graph that we are asked to prove isomorphic. So we can do it 2 ways, but I'm going to do it the longer way so that it is so let us do them together. So the 6 vertices in this case is A, B, C, D, E, and F. And then the edge. Can someone just help me? Just read to me what the edges are. A.
B.
Uh-huh.
D.
B.
D.
B, D. And then?
D, C. D, C.
Okay, I'm going to do C, D instead.
C, A.
C, A. Okay, I'm going to do A, C.
What? I thought they're not there.
E, F. Sorry, say that again, Rafi.
B.
B, E. Keep going. D, F. What else?
C, E.
Sorry, say that again.
C, E.
C, E.
F, A.
What's the last one?
F, A.
Okay, I'm going to try A, F. Okay. If you stare at this really long, what do you think is a mapping that will make them look the same? First of all, one thing you notice is these 3, 1, 2, 3, these 3 do not connect with each other. 1, 2, 3. These 3 do not connect with each other.
I think for the A, B, C, D, E, F one, I think it's that they're like 4 houses, and then inside, and then houses are surrounding to like working places. And then every house is connected to every house plus every working place.
Good interpretation, but we're doing something slightly different here. So if I say 3 of them are not connected, and then 3 of them are not connected, how do you divide those A, B, C, D, E, F into 2 groups? Rafi?
A, D, E, and B, F, C.
A, D, E, and
B, C, F.
B, C, F. One thing you notice is this utility graph, they are actually symmetric. 1, 2, 3 doesn't matter, 4, 5, 6 doesn't matter. So if you swap them, it is actually the same. So to prove it, I'm going to just turn it into this number. AB is 1, 4. Okay. Do we have 1, 5 and 1, 6? This is 1, 6. 1, 5 is AC. Do you know what I'm trying to do? Okay. And then the C and then D. Okay. We have BD, so that's 2, 4. And then we have CD, that's 2, 5. And then we also have DF, which is 2, 6. And then finally we have E is 3. So we have, because we're BE, so this is 3, 4. And then we also have CE, so therefore 3, 5. EF, that's 3, 6. Is it? Can I get a show of sign for people who were in graph theory last time? So this is what we need to prove the two graphs are isomorphic. Okay. Daisy, can you show the sign? Okay.